So, am I audible to you now? Am I audible now? Students, please reply fast. Okay. No, I'm okay. Thank you. So, hello everyone. Welcome to the session. So, we are going to solve some questions of previous year JEE. And yes, hello everyone. Welcome to the session. So, we are actually giving you a capsule course. Like these questions actually are for inspiring you to practice more. Okay. So, student, now let's see a question that came in JEE Advanced 2013. So, what is the question? The question says the work done on a particle of mass m by a force that is given as a function, okay, where k is a constant, okay, and with the appropriate dimensions, so that this expression is a force, okay. So when the particle is taken from point a comma 0 to the point 0 comma a along a circular path of a radius a about the origin in the xy plane. So student, what we have to calculate? Simply we have to calculate the work done, right? So how do we calculate the work done? See, basically, you might have learned in your school that work done is given as the dot product of force vector and displacement vector, right? So students, we can modify this formula for different cases. So if the force is constant, okay, if the force is constant, then simply we use this formula, right? W is equal to F dot S. But when the force is not constant, it's a variable. In that case, what we do, we actually find the small amount of work done and small amount of displacement. Okay, this is a small amount of work done, right? And in order to find the net work done, what we do, we integrate this, right? So W, total work done, is actually what? It's the integration of F dot ds with the proper limits from initial position to final position, right? So in this given question, a very complex, you can see like a very complex function is given, right? So, and one hint is given that the particle is moving along a circular path, right? Along a circular path. Students, little knowledge of mathematics and coordinate geometry is required for this question. You see, let's say, let us see what the situation here. The situation is that a particle is moving in xy plane, right? A particle is moving in xy plane such that initial position is having coordinates. What are the coordinates? A comma 0, and the final coordinates are 0 comma a, right? So starting from a comma 0, this is the initial position. A comma 0. Wait, let's draw a circle first. Let us draw a circle, right? This is a circular path over which the particle is moving, right? So the particle is moving from point A comma 0, that means this point A comma 0 to 0 comma A, right? What happened, Deepak? Student, this is the work, energy and power, and we are calculating the work done. Okay. Okay. So you see, the force is given as its complex function, right? So first of all, what we have to do, we have to find a small amount of work done and small amount of displacement. Let us say the particle is displaced by a displacement ds vector. Now students, as you can understand that this ds vector, okay, this ds vector must be in xy plane because the particle is moving in xy plane, right? So let us say that the horizontal and the vertical components, or you can say the x and the y component of this ds vector are dx I cap plus dy j cap. So what we have done, we have written this the displacement vector, small displacement vector, in terms of its components, right? So dx is the x component and dy is the y component for the small displacement of the particle. Okay. So now when we have to find a total amount of work done, what we do? We integrate. But how? First of all, find a small amount of work done, and that is equal to f dot ds, right? Or I can write it as f dot dx I cap plus dy j cap, right? So students, as you have learned about scalar product, suppose this force has two components. Let's say fx is the x component of the force, okay, and fy is the y component of the given force, right? So I can write this force as fx I cap plus fy into j cap, right? Now student, what we have to do, just substitute this value of force, this expression of force, in the above expression of the work, right? Put it here. So when you substitute this, what do you get? Let's see. What do we get? So dw is equal to fx I cap plus fy j cap in dot product of with dx I cap plus dy j cap. Okay. So we can simply write it as dw is equal to fx into dx plus fy into dy, right? So students, this is the final expression that we have to use in this question, right? So now let us see what are the x component and the y components of the given force. Okay. So in the given question, you can see that this is the x component. You can see, this is the x component of the force. This is the x component and this is the y component. See, what is the x component here? Fx is equal to kx divided by x square plus y square raised to the power of 3 by 2, right? And fy is equal to ky divided by x square plus y square raised to the power of 3 by 2. So now student, this is the fx and fy that we have to substitute in the expression for integration. Okay, now you can see that there's a small hint. There's a small hint given in this question, that is the particle is moving along a circular path. So students, you must be knowing the equation of a circle. What is the equation of circle? You must have learned in your coordinate geometry, x square plus y square is equal to a square, where a is the radius of the circle, right? Yes, this thing we have learned in your coordinate geometry. Okay, student, what we can do, we can substitute x square plus y square as a square in the above expressions for the components of the force, right? So we can write it as kx raised divided by a square raised to the power of 3 by 2. And this the fy component is equal to ky divided by a square raised to the power of 3 by 2. Okay. Now, what we have to do? Just put these values of force, the components of the force, in the expression for the work done, right? So simply substitute the values. So dw is equal to, now what is the value of fx? Simply write from here, kx by a square raised to power 3 by 2. So kx divided by a raised to the power of 3 by c. It should be a cube, because square see 3 by 2 of a square is a cube. Okay, so into dx plus ky divided by a cube into dy. This is a small amount of work done. Now what we have to do, we have to integrate this. So w is equal to integration of dw, and that is equal to integration of kx by a cube, kx by a cube into dx plus integration of ky dy divided by a cube. Okay. So now students, what we can see, what should be the limits of this integration? So you can see from this diagram that this point is the initial position. Okay, this is the initial position, and this one is the final position. Okay, so you can see that x is varying from a to 0, and y is varying from 0 to a, right? So these are going to be our limits. Okay, so substitute here the limits. So x is varying from a to 0, and y is varying from 0 to a. So now simply integrate this. So k by a cube, it can be taken common. You get x square by 2 with the limits a to 0 plus y square by 2 with the limits 0 to a. So now when you put the values, you get simply k by a cube, simply you get k by a cube multiplied by a square by 2 minus a square by 2. So that means the total amount of work done is equal to 0. So that is the final answer that we have to derive. So out of the 4 options, the correct option is D in this case, right? I hope you are able to understand this question. Now let's see the other question, students. Please focus here. So what is this question? This question came in JEE 2010. So what is given? A block of mass. Okay. Okay, Shubhajit, I'll try. Okay. A block of mass 2 kg, a block of mass 2 kg is free to move along the x-axis. It is at rest initially, and after that it is subjected to a time dependent force Ft in the x direction, whose graph is given here. Okay, so this graph shows the variation of F with respect to time. So what we have to do, students, we have to find the kinetic energy after 4.5 seconds, right? So after 4.5 seconds, we have to find the kinetic energy. See, there's only one theorem that you can apply here, and that is work energy theorem. Okay, work energy theorem. Okay, so simply we have to apply here work energy theorem. We have learned about this theorem. What does this theorem says? This theorem says that net work done is net work done by all the forces on the system is equal to change in kinetic energy. Right. This is the work energy theorem. So student, what we have to do? So by this, at least we have to find this net amount of work done. Right. How can you find that net amount of work done? In this given graph, we are provided with Ft, force and time. So we have learned in chapter of force that force time graph, the area of force time graph represents the change in momentum, right? Okay, so we have learned that like F is equal to, you must have learned about this, like F is equal to dp by dt, right? So if you take dp is equal to F into dt, right? So when you integrate this, what do you get? You get net change in momentum. Okay. What do you get? That is net change in momentum, right? So, so that means the area of Ft curve represents net change in momentum, right? So what we are going to do, we will find the net change in momentum. Yes. See, this is the work energy theorem. We have to find change in kinetic energy. So directly we cannot find the work done here. We are not able to find the work done here. So we can't use the work energy theorem directly. Okay. So students, you must have learned about a simple principle that K is equal to P square divided by 2m, where K is kinetic energy and P is momentum, okay, and m is the mass of the object. So what we can do from the given graph, what we can find? We can find the total momentum at the point after 4.5 seconds. Okay. So when you find the momentum after 4.5 seconds, by using this formula, you can find the kinetic energy at that point, right? So let's come back here. So now students, so you can see that in a given question, we are provided that it is at rest. Okay, initially it is at rest. That means initial momentum is equal to 0. Okay, So as you can understand that FT curve represents the change in momentum. Okay. So that means whatever be the value of momentum at this point will be the final momentum because initial momentum is 0, right? So how to find the area of this curve? Simply, you can find by using like half into base into height because you have two triangles. But still, we don't know about this point. What is the value of force here? Students, you can see that this is a straight line. Okay, this is a straight line. Okay, and in a straight line, you see the slope is constant. Okay, the slope is constant. Let's take this point as point A. And the coordinates of this point should be 0, comma 4. And talking about, let's say this point is B. And the coordinates of this point are 3, comma 0. And let's say this point BC. And the coordinates of this point are, let's say, the value of force is F. Okay. So 4.5, comma F. We are assuming that the value of force at the point C is F. Okay. So use a simple formula for slope. Just calculate the slope for AB and BC. You'll get the value of F simply. How can we do this, students? Simply find the slope of AB. Okay, so slope of AB is simply right here. So 4 minus 0 divided by 0 minus 3. So that is equal to minus of 4 by 3. And then find the value of slope for BC, right? So MBC is equal to, let us say this point B and C. Okay, so it's 0 minus F divided by 3 minus 4.5, right? So that is equal to F by 1.5. Now, as ABC are lying on the same line, so slope of AB and slope of BC must be equal, right? So simply you can equate here just F by 1.5 is equal to minus of 4 by 3. So by this, students, you can find the value of F, and that is equal to minus 4 by 3 into 1.5, or simply you can say it's minus 2 Newton. Okay, so that's clear to all of you. So yeah, now what we have to do, we have to find this area. Okay, the area by see area covered by FT curve. Okay, area covered by FT curve. Okay, so this area we have to find. So let's find the area. So you can see that in the area can be found simply half. Wait, let's see white color. So area of FT curve. What is that? Simply write half into 4 into 3 and minus half into 1.5 because this difference is 1.5, right? This difference is 1.5 and this height is 2. So simply find it. Half into 2 into 1.5. So simply you can write it as 6 minus 1.5. And that is equal to 4.5. Okay. So the units of this should be same as that of momentum, kilogram meter per second. Okay. So use a simple formula. K, see what is this? What what you have find, what you have found here. This is what? This is the final momentum at, at 4.5 seconds. So use simply K is equal to P square by 2m. Simply substitute here. So 4.5 square divided by 2. And what is the mass? You can see the mass is 2 kg. So put here the value of mass also. So what do you get? You get around 5.6025. So the correct option is C, right? Preeti, see, by the area, Preeti, by the area of this FT curve, we are going to find the momentum, the change in momentum, right? Okay. So I hope you are able to understand. Please see the recording after the class. You can, you know, better understand after that if you are having doubt here. Okay. So let's see this question, students. What you're saying, Samir, in the previous question, how did we put the equation of circle in the equation of work done? See, Samir, in the previous question, we have substituted, we have substituted x square plus a square equal to a square. See, x square plus y square equal to a square. Right, you can see here, the previous question, wait, let me show you. In the previous question, we have just substituted x square plus y square equal to a square. Okay, and we simplified the value of force. Okay, and nothing related with the equation. Okay, beta Sumit, you can see the recording later on. Okay, you can see the recording better. It's okay. Now, students, this question gives us a very important concept. See, what is the question? The question says that a particle is placed at the origin and a force F is equal to kx is acting on it. Okay? So, now where k is a constant, is a positive constant. Okay? So, if U0, that means, what is U here? U is the potential energy. Okay? And the graph of Ux versus X will be. So what we have to find, students, we have to find the Ux. That means you can say potential energy as a function of X, right? What is X? X is displacement. Okay. So students, you can understand. See, basically, you should understand one thing, that is that potential energy is basically defined for conservative forces, right? For example, spring forces, or you can say gravitational force, electrostatic force. So potential energy is basically defined for these kinds of forces, right? So you should know one concept, one formula, that, see, what you should know, that F conservative, the conservative force, is equal to minus of du by dx. What is u here? U is the energy, x is the displacement, and F conservative is the force. Okay. And also you should note that that the work done by a conservative force is equal to negative of potential change in potential energy. Negative of change in potential energy. Two things you should note down. Okay. Now let's see the question. Question says that we have force is given as F is equal to kx, right? This is the value of force. So, and it's acting in the positive direction, right? Because k is constant. See, k is a constant. Okay. So F is equal to, in the color, F is equal to kx, right? And we have to find potential energy, and that should be equal to minus of du by dx. Okay. Yes. So by this, you can simply write du is equal to minus of kx into dx, right? Now simply integrate this function, okay, du, integration of du gives us minus of k, let's take k outside of integration, so x into dx, right? So that's equal to minus of k x square by 2. Okay. So students, you can understand that this ux, what do we get from this integration? We get ux, u as a function of x, right? So we got ux is equal to minus of kx square by 2. Okay. So you can see this is the equation of a parabola. Okay. It's the equation of a parabola, right? Because x square is there. But due to negative sign, it should be an inverted parabola like this, like this, like this. Because negative sign is there. If it were positive, the graph would be like this. Okay. So in this case, the correct option is A. Okay. So students, I hope you learned a lot and you loved the session. So all the very best for all the to all JEE aspirants from my side. So please prepare well, okay? And to know more how Meritnation can boost your preparation, you can see the link that is given in the information. So thank you so much for giving your time. So all the very best. Thank you.